Well, in the section on logarithms in the textbook, the number e is introduced, and there are some explorations that help you see, how that special number, that special irrational number e, what properties it has and how it was developed. And it came from the amortization schedule, which is an ages-old equation that allows you to figure out how much interest you owe on a loan, or if you're the bank, how much interest you'll make on a loan. And because it has such a financial backing, this is something that's been of interest to humans for thousands of years. If you take a look at that amortization schedule at its most bare bones point, the number e falls out of it. And there's an exercise in the text that will help you see that. It was Leonhard Euler who really studied E extensively, and Euler's last name starts with E, so in homage to him, that special number is given the name E, and so e to the x is an exponential function, and of course its inverse function is the natural log of x. And it's called natural just because it arose so naturally in our studies of logs and exponents related to this amortization schedule. Once you get to college algebra and above, and all college mathematics courses, there's no more log base 10 or anything. Because of the change of base formula, everything is expressed as e, exponential function e to the x, or the natural log of x, the log function. I must mention that logs were developed by a French mathematician named Napier, John Napier, and he named it logarithms because he thought it was logical arithmetic, and that was his condense of the two words, logical arithmetic, logarithms. And it's no coincidence that the Age of Enlightenment, in the 1650s to 750s, in Europe was a time when mathematicians and scientists, who were all called natural philosophers because they did both, really made so many discoveries, so many just foundational discoveries in math and science. And one reason this came about is because of Napier and his logarithm tables and logarithms, because logarithms take big numbers and make them into little ones. They take exponential numbers, exponential growth, and really just make them into looking at the exponents, which are much smaller than the number. So you can look at these exponential functions in a log way and then transfer your results at the very end. And without calculators and computers, this was huge. It saved hours of computation to be able to look at things in a log way. You may have heard of slide rules, which is what I used instead of a calculator growing up. Now they're just in museums somewhere. But they were able to take big numbers and make them into small numbers, easier to work with, using this logarithm idea.